Hey Hayden, it's Miss Tracy. So let's look at the ones that you had questions about from 76. I'm just going to go through all the problems you got wrong. So here we have an urn contains 8 gold and 7 silver coins. So let's draw us an urn. And then we have gold coins. So let's do 8 gold coins. 1, 2, 3, 4, 5, 6, 7, 8. And we'll use blue for silver. We have 7 of those. 1, 2, 3, 4, 5, 6, 7. All right, so you really don't have to draw the picture, but I like to because it's fun. All you really have to do is say I've got 8 gold, 7 silver, and then total them up, which would be 15 total coins. So then you want to find your probability statement. Your probability statement is going to be the P with the parenthesis here. And then the order of things that you want. So you want the first coin to be gold, so G, and the second to be silver, that's S. So now we're going to look and see what our values for each one of those are. So for the gold coin, 8 out of the 15 coins is gold. For silver, 7 out of 15 is silver. 7 of the 15 coins are silver. So 8 out of the 15 are gold, 7 out of 15 are silver. We just multiply. You just multiply straight across. So 8 times 7 is going to be, oh geez. I was never good at my 7s and 8s and memorizing them. I think it's 56. That sounds right. And then 15 times 15, I cannot do that in my head. I think it's 125. We'll find out. 225. See, I was off by 100. So 225. That's your answer. That is your answer. 56 over 225. And we know it's the answer because the only factors of 8 are 2 times 2 times 2. And the only factors here is 3 times 5 and 3 times 5. There are no factors we can cancel, so we can't reduce this at all. It is what it is. That would be the answer to that problem. All right, hold on. We'll go get the other problem. All right, here's the next one. It says, what is the y-intercept point for the equation y minus 2x equals 1? So in order to find out what the y-intercept point is, we've got to put this in the right format. And that means x has to be on this side because the right format is y is equal to mx plus b. And then it wants to know what is this number right here because that's your y-intercept point. So let's add 2x to both sides. So then we'll put it in this format. Y is equal to, the x term goes first, and then we have a positive 1. So this number here is this. So the y-intercept point for the equation is 1. Okay? And you could have put positive 1 too. I think it's just 1, but that would be the answer. Let's look at the next one. All right, I am not sure what you were doing here. You were supposed to put this in standard scientific notation, okay? Standard scientific notation tells us that we need to have a ones place times a 10 and an exponent. That is standard scientific notation. Now you can have a decimal after here, but you need to have only a ones place. So we can't have a thousands place or a hundreds place or a tens place. It just has to be a ones place. So we're going to move the decimal for that to happen. So we have 4,300 times 10 to the 7th power. Okay? So what you want to do is you want to move the decimal to the left, which means it's going to be a positive exponent. So 1, 2, 3 plus 3. 4.3 times 10, 7 plus 3 is 10. That's all you're doing. And I clearly explained this in the video. So I think that maybe you might either A, not be watching the video the way you should and taking notes. It's also in your workbook. But B, the background music might be putting you to sleep. I apologize for that. But going forward, drink some coffee, have some sugar, watch the video, take some notes, This is standard scientific notation. A ones place only for whole numbers, and then you can have a decimal, and then this is times 10 to whatever power it needs to be to get this number to its final value. Okay? All right, let's look at the next one. All right, so this is to factor the binomial. We talked about this in the video. This is a perfect square. Perfect square means that you're going to follow the format of the unsquared first value minus the unsquared second value times the unsquared first value plus the unsquared second value. It's always that way. And in order for you to do that, it has to have a minus sign here. This, and this. All the parts of both terms have to be perfect squares. So we know the square root of 4 is 2. Square root of x squared is x minus square root of 9 is 3. Square root of m squared is m. Now you just rewrite that with a plus sign. Blank 1, blank 2. That's what you're looking for. Okay? There's a pattern. There is a pattern. Now, if you were to multiply this, you would find, how this is true. And that's because the first and last multiplication cancels. And I don't know why I wrote, this without the 3. I should have had a 3. Sorry about that. So you'll find that they cancel each other out. So 2x times 2x is 4x squared. Right? Negative 3, actually let's do 2x times positive 3m. This will be positive 6xm. Negative 3m times positive 2x is negative 6xm. Negative 3m times positive 3m is a negative 9m squared. These terms here and here will always cancel each other out. So all you're left with is the first times the first, and the last times the last. So 4x squared minus 9m squared. But that's what you're doing. Unsquare the first number, first term, minus unsquare of the second term, and then repeat that with a positive sign in between. And that's it. You do that for every single one of those binomials that you need to factor. If it has the minus sign in it, it's telling you it's a perfect square. All right, let's look at the next one. All right, I don't know how this one got marked right because it was not correct. So I'm going to go and check that out. But it's just to factor the binomial. We can't do it like this. It says 2x squared minus 72 k squared. That's what it should be written as. You have to redo it with the minus sign in the middle. And then you have to look and see, okay, is this a perfect square? It's not. It's not. So we have to see if we can adjust it to make it a perfect square, and we can. So we factor out the 2. We divide this by 2. We get 1x squared minus 72 divided by 2 is be 36k squared. This can be factored. So what we actually have here is 2 times x minus 6k times x plus 6k. Because this is a perfect square. X times x is x squared. And negative 6k times positive 6k is negative 36k squared. So sometimes you have to adjust it just a little bit. I think that I've checked the box that says accept math equivalency, and it just looks for the numbers. It ignores the variables, so I'm going to have to take that off. But this, what you had was 2, negative 6, and positive 6, and that's wrong. The first one is right, but you have to have the binomial for it to be right. So I have to grade that manually, go back and fix it so I can give you the credit. Let's look at the next one. All right, this one says use substitution or elimination to solve. So you have a choice. But in looking at the problem, excuse me, I've been making a lot of videos today. In looking at the problem, it's obvious to me that we can use elimination because these two are opposites. So if we just draw our line, you can cancel those out. Combine these, it's 5x. Combine these, that's 10. Divide both sides by 5. X is equal to 2. So now I could pick one of these. I'm going to pick the first one. 2x plus 2y equals 14. I'm going to take the value of x. 2 times 2 plus 2y is equal to 14. 4 plus 2y is equal to 14. Subtract 4 from both sides. 2y is equal to 10. Divide both sides by 2. Y is equal to 5. And your answer should be 2, 5. Just like that. All right, let's look at the next one. All right, we're going to write the numerator terms in the top blanks with their signs and the denominator in the bottom blank. So in order for us to combine all of these together to add them, we have to find a common denominator. And the easy way to do that is to factor everything, but it's time consuming. You can also just look for the variables. When you have all variables here, you look for the variable with the highest exponent. And here the x has a 3, that's the highest exponent. And the a's highest exponent is 2. So a squared x3, that's your common denominator. Okay? All right, so now we're going to multiply this times what's missing, all right? All of these times what they don't have of this. So the first one needs an a square and an x. So a square x over a square x times a over x squared. Because when you multiply these together, you get this. So that's why we're multiplying the whole fraction times what's missing. Now we have a plus, and now we have ax squared. Well, what's missing, I need another a and another x. So ax over ax times 2 over ax squared. Plus, I have an x cubed. What I don't have is an a squared. So I need to multiply a squared times the top and the bottom for this term. Minus, now this is an a squared, but it doesn't have an x cubed. So I got to multiply by x cubed times the top and the bottom. Now I do all the multiplication. If I do this times this, I get a cubed x over a squared x cubed plus 2ax over a squared x cubed plus a squared b over a squared x cubed minus x cubed over a squared x cubed. Okay, so there's our 4 terms, but now that they all have the same denominator, we can combine them together. So I have a cubed x plus 2ax plus a squared b minus x cubed all over a squared x cubed. That is your answer. And you would type each one of these individual terms into a blank, and then this would go in the bottom blank. And that's how you would enter it in. So this would be one box, this would be a box, this would be another blank, and this would be another blank, and then this would be a blank all by itself on the bottom. That's how you would type that in. All right, let's look at the last one. Okay, so the one thing I want to point out with these is we're stressing with Saxon math. It stresses mental math. It doesn't want you to put it in a calculator. It wants you to do as much of it on paper as you possibly can. And we do not resolve these to decimals. We have not done that in any of the videos. So if you are watching the videos, then you know how I want you to answer the problem. So because you gave me a decimal, that tells me you're not watching the videos, because you're not giving me the answer to the problem in the format that I am asking for it, okay? Watch the video. So here we have to simplify this problem and get a result. In order to simplify this problem, we have got to reduce these radicals as much as possible. And the way we do that is through factoring. So we know that 20 is 4 times 5. we know that 80 is going to be 4 times 20, which is 4 times 5, right? We know that 125 is 5 times 25, and 500 is going to be 5 times 100. So let's see what we can reduce now. So I know square root of 4 is 2. 3 times 2 is 6 times the square root of 5. We can't remove the 5. It stays in there. We've got a pair of 4s here, so we can pull them out. That would be 16. Square root of 16 is 4. 2 times 4 is 8 times the square root of 5. Here, I know the square root of 25 is 5. So 2 times 5, that's 10 times the square root of 5, the one that's left over. And I know the square root of 100 is 10. 10 times 10 is 100. So minus 10 times the square root of 5. So we have plus 10 times the square root of 5 minus 10. Those cancel each other out. They're not even part of the problem. So here we have 6 minus 8. Both of them have the same radical. So what that's going to be is a negative 2 times the square root of 5, because 6 minus 8 is negative 2. And we can do that because they both have the same number underneath the radical sign. They're like terms. We treat this like a variable, and the base is the number, the variable is the number, and if it matches, then we can combine it. It's the same thing as if we had done 6x minus 8x would be negative 2x. That x is your square root of 5. Okay? All right, so this would be the right answer for that problem. All right, and that's all we had for lesson 76. Those were all the ones that you missed, and took us 17 minutes to get through them. Watch the videos. Take notes in your workbook. Write out the practice problems in the videos as you watch them. You're not going to get this if you don't. That's the whole point of the workbook, is so you can go back and look in the workbook and say, this is how I solved the problem. Okay? Yes, ma'am. All right. Now, your mama is smart, and she can help you figure this out, right? She's already been through it with Addison. So I know that she can help you solve some of this. Ask her for help. Bribe her. Give her something. Like, oh, I don't know, wash dishes for her, or wash her car, detail it. Get her to help you. Your mama's smart enough to do it, and she's already been through it with your sisters. So look at her as a resource and treat her with respect. You are lucky to have a mama who wants you to do well and invests in you by watching the videos, because she's seen them too. All right, I'm going to quit preaching. Have a good week. I'll see you later.